Hey, what's going on, guys? Oh no, that is disgusting, Hannah. Like I said, Hannah, I'm gonna do 3 questions today, and then tomorrow I'm gonna do 2 more questions. They're gonna be very similar, so you'll be all right. So I'm not sure how many other people are coming. I just realized I forgot an extra parenthesis right on my first line. Whatever. Um, I should have another parenthesis right here because that g of x is supposed to be on the inside. But I think today should be a pretty quick lesson. I'm going to explain to you guys how today works. Um, what we're going to do is we're going to be looking at these functions as an inside and an outside. So I'm going to write it kind of similar to what we did last time, as f of x and g of x, and then we're just going to find the derivatives, and instead of cross multiplying today, we're just going to multiply straight across. Okay, so first of all, what I'm going to do is f of x is going to be recognized as, I'm going to say f of x is the outside, and the reason why I'm saying that is based on how I wrote it over here. The f is on the outside, so I'm just going to call that the outside function. And then we're also going to have g of x, which is going to be recognized as the inside function. So when we go to find the derivative of a composition function, when you have an inside and outside, what we have to do is find the derivative of both. So f of x is going to be represented by the whole thing. It's the x cubed plus 3 raised to the 5. And the g of x is only going to be represented by the inside of those parentheses, which is x cubed plus 3. So what I'm going to do is, just like last time, I'm going to find the derivative of both of those. So this blue one, we haven't really done much of these with derivatives, but I'm going to show you guys it's identical to what we've been doing. When we have the derivative, we just take the exponent, and in this case, it's going to be the exponent on the outside, and bring it out to the front and multiply, just like we've been doing. So the number that's out front right now is a 1. So I'm just going to do 5 times 1, which would be 5. The inside does not change because we're going to be doing the derivative for that separately. And then we have to subtract 1 from the exponent, which is just going to be 4. That is the derivative for f of x. We're done. We don't have to do anything to the inside of the parentheses because we are now going to do that over here. So now, just like the last week, I'm going to find the derivative of x cubed plus 3 by bringing the 3 out front. So I'll have 3x. I'm going to subtract 1 away, so it'll be squared, and that 3 is gone. The chain rule I find a little bit easier, especially the ones that we're going to be doing now. There technically are more difficult chain rules. It goes into trig. Some of them have chain rule, product, and quotient rule all inside of them, and it can take up like half a page. We're not going to do anything like that this year. This is going to be the last new thing I'm going to do with you guys is just chain rule, and then we're going to call it quits for new stuff this year. But yeah, and now that I have both those derivatives, the formula or the chain rule states if you start off with the composition function, if you have something on the inside and something on the outside, all you have to do is just take the two derivatives and multiply them together. So now if I want to completely solve this problem, I'm just going to take this and multiply them. So I'm going to have, I'm just going to multiply it right now. So I'm going to multiply the numbers that are on the outside of the parentheses. So I'll have 3x squared times 5, which would be 15x squared, times it by x cubed plus 3 raised to the 4th. I can't go any further than that because I would have to simplify the parentheses down by writing it out 4 times. I'm not going to make you guys do that. That will really expand this problem out. So I am okay if we just leave it like that. So there's no cross multiplying when you guys do chain rule. That's only when it's a product, if you're multiplying two things or if you're dividing with the quotient. Okay. So the second one, I'm going to walk through the same steps. It's going to be very, very similar, just different numbers. I got to say what the outside is, and I have to say what the inside is. Now the outside is just the same exact problem. I don't have to change anything with it. And now I'm going to find the derivative of that. I'm only doing the derivative of the outside exponent because the f of x is outside. So when I go to do the derivative of this, I just want to bring the 3 out front. Again, the number out front is just 1. So I'm going to bring the 3 out front. So I'm going to have 3 times negative 3x to the 5th plus x squared. And I'm going to be left with a 2. Okay. Now that I got that, I got to do the derivative for g of x. So g of x is the inside. So now I just have to do the derivative for those. So g prime of x would be equivalent to negative 15x. We're subtracting 1 away to the 4th. Plus, I'm going to bring the 2 out front. So I'm going to have 2x. And I'm going to subtract 1 away. Now the last thing we have to do is now the chain rule portion. We have to multiply the two derivatives together. So when we go to multiply both of these together, again, you cannot multiply it with the big parenthesis. You can only multiply what's outside. So I can take that 3 and multiply it to both the negative 15x to the 4th and the 2x because I could distribute it to that. So I'm going to multiply it to those, and I'm going to get negative 45x to the 4th plus 6x. And technically, all of that still needs to be multiplied to the negative 3x to the 5th plus x squared. Okay, so all I'm doing is I'm just multiplying. If you guys are having trouble seeing what I'm doing, I just took this 3 and I distribute it to that g prime of x. Oh, my highlighter didn't work for some reason. I multiplied it to this whole thing. Same thing up top. I took this 5 and I multiplied it to the 3x squared. And then I just wrote the parenthesis right next to it. Okay. The last example I'm going to do with you guys today is the same thing, except the exponent is negative. Again, I want to do these negative ones with you guys because some of you guys are writing the wrong thing in for the exponent. So I just want to be consistent and just make sure I'm still giving you guys the practice. So f of x is going to represent the whole thing. And it's not writing. I'm writing. I don't know if it's going to write. We'll give it a second. Oh, but that's why it was trying to create a circle apparently. So I got negative x to the 4th minus 3 to the negative 2. Again, when you guys go to do the derivative, why does my pen stop writing? Is it dead again? Oh, I'm at 2%. Yeah, that might do it. So when you guys go to do the derivative, you're going to have to multiply the negative 2 out front. And again, in front of the parenthesis is just 1. So I have f prime of x is equal to negative 2 of negative x to the 4th minus 3. Now this is where you got to be careful because you are subtracting 1 from the exponent. As I'm going through and grading some of your guys' papers, I'm still seeing you guys saying negative 2 minus 1 is negative 1. Negative 2 minus 1 is actually negative 3. So make sure you're being careful with that. And then the other side is just the inside. So I have negative x to the 4th minus 3. So I can bring that 4 out front, and I'm going to have negative 4x to the 3rd. And that 3 at the end is just going to disappear because it's really going to be 0. And now I'm going to multiply both of these again. So again, you can only multiply those outside numbers unless you really want to reduce what's inside the parentheses. I'm not going to reduce that down. I'm not going to write it out 3 or negative 3 times So I'm just going to multiply these, and I'm going to get 8x to the third, and I'm just going to write the parenthesis next to it. And that's all chain rule really is. The more complicated ones are going to be the ones we go to do on the back when we start working with square roots. And then they get even more complicated, as I said earlier, is when you start going into the trig functions, the sine, cosine, and tangent. I am not going to teach you guys those derivatives this year. That's for the people that plan on going into calculus or having to take calculus in college. Okay, so that's all I got. Enjoy the next couple days because the rain is a coming. Okay, so I will see you guys later. Have a good one.